Hi everyone, this is Module 4, Lesson 3. Today we are comparing quantities with percent, and our essential question is, how can we set up real-life percent problems as well as problems that represent more than one whole? So as you see that more than one whole, you can already tell in the opening exercise that there's one whole square plus some more. So let's go ahead and talk about this opening exercise. If each 10 by 10 unit square represents one whole, then what percent is represented by the shaded region? Okay, so the shaded region would be all of this one and these ones here. So we know that the first one is equal to 100%. So let's go ahead and write that on there. And then this one, you don't really need to count. I know that a lot of you want to automatically start counting, but you know that this is 10 and this is another 10. And then you just have to count that this is 5. So that's 25 out of 100, which is 25%. Okay, so altogether, that equals 125%. And that's really all that you have to do on this one. Okay, now they tell us that 25% represents a quantity of 10 students. So 25% equals 10 students. There's many, many ways that we can figure out what the shaded region represents. We know that the shaded region is 125%. So there's many ways that you can do this. You can set up a proportion. You can say, well, 125% is equal to 100% plus 10%, or sorry about that, 100% plus 25%. And then you could figure out how many students would be in this box here, and then how many students would be in this box here. Okay, you could also make a proportion. Now, I told you to put 100% on the bottom, but in this one, they're not really asking for 100%, they're asking for 125%. But the good thing is you can still solve using 10 students being 25% and then solving for x for 125. So you can do it either one of those ways. What I'm going to do is I'm going to show you that if 25% is 10 students, how many 25% are in 125%? And if you're not sure, think like money, like how many 25s go into 125, or how many quarters would that be in $1.25? Okay, if you figured it out, you can keep listening. If not, you can pause it and try it. There's 5 times, okay? So what we can do is we can take those 10 students and multiply by 5. And that gives us 50 students total. Okay, and like I said, you could also use the cross products here. 10 times 125 is equal to 25x. Okay, so each 25% is 10 students. One last way to make this make sense to you, I'm just going to abbreviate it. We have 25% is 10 students. Now, if we have another 25%, that would be another 10 students, another 10 students, another 10 students, another 10 students. So if you think of it, really what we're doing is we're adding up all these 25%, which is 125%, and then 10, 20, 30, 40, 50 students. Okay, hopefully that one, if the other proportions and explanation didn't make sense, hopefully this is a good visual for you. Okay, let's turn to page 17. The members of a club are making friendship bracelets to sell to raise money. Anna and Emily made 54 bracelets. Okay, anytime I see the numbers, I want to make sure I'm paying attention over the weekend. All right, for part A, they need to produce 300 bracelets by the end of the week. What percent, that should be your clue actually. When you hear that phrase, what percent, that should be your clue that in our proportion, the x is actually going to be the percentage because we don't know the percent. They're asking for the percent. What percent of the bracelets were they able to produce over the weekend? Well, if they need to produce 300, that's the total, and they already produced 54. Now, I know you can solve that, so pause it, see what you get, and then unpause it to see if you're right. Okay, did you get that x equals 18%? So they already made 18% of the bracelets. Okay, now for part B, it's a little different. For part B, it says that Anna produced 32 bracelets of those 54 produced by both of them. Okay, so hopefully this makes sense to you. Together they made 54. Anna made 32 of those. Okay? Write the number of bracelets that Emily produced. Okay, that's interesting because they didn't tell me anything about Emily. As a percent of those that Anna produced. Okay, wow, we're going to have to slow down and break this apart because this seems really confusing, this part, because it's different than what they gave us. So they want the number of bracelets that Emily produced as a percent of those that Anna produced. That means that Emily is going to go over Anna. Okay, they want Emily's to be the part and Anna's to be the whole. All right, so we know that when in doubt, we can put 100% here. Again, it says as a percent, so we don't know what the percent is. We know that Anna produced 32. The problem is we don't know how many Emily produced. So can I have two X's? I really can't do that. I wouldn't be able to solve for anything. What we can do, though, quickly off to the side is do 54, the total they made, minus 32, the amount that Anna made. And that leaves us with 22 for Emily. Okay, so Emily made 22 because Anna made 32. Okay, now you can pause it and solve it and see what you get for X. Okay, did you get 68.75%? Remember, we're multiplying and setting up our equation. It's 22 times 100 equals 32 times x. If you didn't know how to solve it, go back and watch lesson 2 to help you with these. Okay, rewatch lesson 2 if you're not sure where I'm getting these answers from. Okay, so that's Emily compared to Anna. Part C says write the number of bracelets that Anna produced as a percent of those that Emily produced. Okay, that sounds like the exact same question, except they want Anna compared to Emily. So now let's write Anna over Emily. Okay, and now it's going to look very, very similar, except that Anna made 32 and Emily made 22. We're still looking for it as a percent. So here's the deal. Usually, we have a smaller number as the part, a bigger number as the whole. Smaller number as the part, bigger number as the whole. You can have a bigger number on top than on bottom. Hopefully, you can predict what will happen to the x. If the bottom number is 100 and 22 is smaller than 32, what do you think will happen with the x? Hopefully, you're thinking that it will be more than 100%. And it is going to be more than 100%, and that is possible to have a percentage more than 100. Okay, go ahead and solve it, and if it repeats, hint, hint, it does, go ahead and put the repeating bar over the part that repeats. Okay, if you are listening and watching, hopefully that means that you paused it and tried it. It is 145.45% repeating. If your calculator gave any of these as a fraction, that's great. That's totally fine. You can leave it as a fraction. Okay, in exercise 1, there are 750 students in the 7th grade class and 625 in the 8th grade class. Are you marking the text as you read? At Kent Middle School, what percent is the 7th grade class of the 8th grade class? So we want 7th grade versus 8th grade. Okay, so when you set it up, make sure that you keep the 7th grade on the top and the 8th grade on the bottom. We know that we can put 100% down here, and since it's comparing it to the 8th grade class, that's the total. Okay, very simple now. 7th grade is here, 8th grade is here. So that means the 750 goes on the top and the 625 goes on the bottom. Okay, and then obviously the last part is the x. So use your cross products and go ahead and solve. Okay, pause it if you haven't, and make sure that you show your work. And what did you get? Hopefully you got 120%. So let's write it actually as a sentence so it makes sense. 7th grade is 120% of 8th grade. That's because the 7th grade has a higher enrollment. In fact, speaking of enrollment, the principal will have to increase the number of 8th grade teachers next year if the 7th grade enrollment exceeds 110%. So exceeds means to go over. So if it goes over 110%. And the answer is yes, because 120% exceeds 110%. Okay, so the enrollment did exceed 110%. All right, on exercise 2, we're still talking about Kent Middle School, but we are talking now about band and choir. So there are 104 students in the band and 80 students in the choir. What percent of the number of students in the choir is the number of students in the band? I want you to try this on your own. Go ahead, try this on your own. You know what to do to get started. You can at least write the proportion. You can at least put in 100%. Now, what I would say is to make sure you know which goes on top and which goes on bottom. Hopefully you knew that it was band and choir. Okay, go ahead and set it up, solve it, and see what you get. Then you can unpause it. Okay, if it was band over choir, it's 104 over 80, and that would be X percent over 100%. When you solved it, it's 104 times 100, which is equal to 80x. Okay, and then 104 times 100, if you know the shortcut, if it's a whole number times 100, you just add 2 zeros. And 80x, then we divide both sides by 80. And you should get 130%. That's because the band, the amount of kids that are in band is more than the amount of kids that are in choir. In fact, the band is 130% of the choir. Okay, we're going to skip exercise 4. Again, I want you to try exercise 3 on your own. Okay, top over bottom. How do we set this up? So in other words, which goes on top, the breakfast or the lunch? Go ahead and fill in these two words, here and here. Which one do you think goes on top? Which one do you think goes on bottom? Okay, so hopefully you knew that it was the lunch compared to breakfast. So hopefully you did lunch over breakfast. So when you fill in the proportion below, you remember to put the lunch amount over the breakfast amount. Okay, and so for the next box, go ahead, set up and solve. Then unpause it and see how you did. Okay, if you are listening or watching, hopefully that means that you did unpause it and you're going to see how you did. If I want the lunch over the breakfast, we want 375 over 125. Okay, and then when you do the cross products there, you can go ahead and solve. And I feel terrible because I think I actually misread this one. What percent of the lunch is the cost of breakfast? They gave this one out of order. So if you were to solve that one, that's fine. Go ahead and solve that. I had it right in my book. Sorry, guys. If you had that, it's 300%. So I am really sorry. Go ahead and do breakfast over lunch. Hopefully this is a good learning moment for us that, yes, I can read it and misunderstand it. The what percent, we're obviously still looking for percent, but it says what percent of the lunch is the cost of breakfast. So it actually wanted it to be breakfast over lunch. And in that case, it would be 1.25 over 3.75. Then when you solve this one, you can pause it if you want to see if you would get that right. And that one is actually 33 1/3%, or 33.3 repeating. Again, I apologize, but I don't mind that you're hearing this because you know that no one's perfect and that I made a mistake on that one. I accidentally did lunch over breakfast, but it really was supposed to be breakfast over lunch. What percent of the cost of lunch is the cost of breakfast? Very confusing how they, at least in my opinion, maybe you caught it, but in my opinion it was confusing because it kind of made the words backwards. So it should have been breakfast over lunch. Okay, and then, like I said, we're skipping exercise 4, and then you can do the summary, and that is a wrap on lesson 3. Thank you, everybody.